JMath.
In this video, we will be looking at calculus word sums, but specifically those related to area, perimeter, volume, and surface area. So you need to remember from your primary school and in grade 10, when you guys studied these formulas, the ones on screen, they expect you to know. Okay, so it's not every year where you get a question on this, but they do not have to give you the formula if any one of these are asked. Okay, if it's a cone, a sphere, a pyramid, or a prism, or any other weird shape, then they will have the formula on the paper for you. Many times they just don't give you a label next to the formula, so you won't know if it's area or volume or surface area, but you luckily don't need to memorize all the formulas that exist off by heart. Let's look at question 1, and then I'll discuss the steps you need to follow with these questions. So firstly, the steps. Set up a formula with the info they give you and use x and y or whatever variables they give you. Just use two variables there. Step 2, look at the question. If there is an x, get the other variable alone in your initial equation. So I'll do this question 1 with these steps, and then I'll show you exactly what I mean. Step 3, set up a formula that they are asking for. So in this case, they're asking for the area formula. 4, for minimum or maximum, make the derivative equal to 0 and solve. And then sometimes they ask for the x value, but sometimes they ask what is the maximum or minimum value. Then you need to sub back into the formula that you got. Okay, enough preaching. Let's get to this question so you can see how to do it. Question 1, the diagram below represents a printed poster. Rectangle ABCD is the part on which the text is printed. The shaded area ABCD is 432 centimeters squared, and AD is x. Okay, now in my steps, you would see I said for step 1, set up a formula with what they give you. Now this is the part I'm talking about. So always in these sums, they'll give you a certain part of the info, and then they'll ask you something else. So they give me the area of the shaded part, but in the question, they ask me for the area of the page. So it's two different areas that I'm working with, but you always need to start somewhere. Now, I know that area of a rectangle is just length times breadth. So for this shaded area, I can say 432 would be equal to length times breadth. Now, in this specific question, the length would be AD, and the breadth would be AB or DC. So in the given info, I can see AD is equal to X, and therefore I'm going to make AB equal to Y. That is what I said in step 1, put in a formula with X and Y. Okay, now the rest of the question. ABCD is 4 centimeters from the left and right edge, and 3 centimeters from the top and the bottom. Question 1, show that the total area of the page is given by that horrible formula. Okay, so I needed to start somewhere, and I started with the shaded region because that is where my X is, and that is where the info is that they gave me. But now the question is asking for the entire page. Now, I know that AD is equal to X, but it goes a little bit further and a little bit further. So I can say the length of the page is actually equal to X plus 8. Okay, and now I need to find if that's the length, I need to find the breadth. So the breadth would be AB, but plus 3 plus 3. So for breadth, I can say it is AB plus 6. And we saw that AB was actually equals to Y. Okay, so now I can make a formula for the big page because I know it's just length times breadth. So I'm going to say area is equal to the length, which I saw was X plus 8, and then the breadth, which I saw was Y plus 6. Now I have a little problem, and that is what I said with step 2. If I look at the formula, there's no Y in that formula. So what I'm going to do to compensate for that is to take this blue formula with a Y in it, and I'm actually going to get Y alone. So I can say, but Y is equal to 432 over X. And that's what I'm going to sub in, and that's how I'm going to get to that big formula that they are talking about. So now I'm closer to their formula because I only have x's, but now I can just FOIL out, and then I will hopefully get to where they are. So if I do the first, so I'm multiplying x by 432 over x, that just gives me 432. The x's would cancel out. Then I'm multiplying the x by the 6, and that gives me plus 6x. Now I'm multiplying the 8 by that blue fraction. I don't know what it is, but I'm expecting it to be 3456. So just type it in the calculator, and you would see that it is indeed that number, and then plus 48. In simplest form, that would then be 3456 over x plus 6x, and then plus 480. And there we go. I solved question 1. And now, most of the time, that is the difficult question out of the two, because the last one, if they just want the x for the total area, I can just do step 4 that I said, which is just get the derivative and make it equal to 0. So just because I'm running out of space, I'm just going to do question 2 right here, which would then be, okay, I want the derivative of this, but remember your rules of differentiation. If there is an x in the denominator, I'm not allowed to differentiate. So I'm first going to stick to orange and just say, okay, so my a of x formula would then just be equal to 3, 4, 5, 6 times x to the power minus 1. The rest is fine, plus 6x plus 480. And now, if I get the derivative in terms of x, I can say this is minus 3456 times x to the power minus 2. I'm just going to bring it down. And then just a plus 6. Perfect. I want the minimum or maximum, so I can just make it equal to 0 immediately. And for this, I'm just going to keep the 6 where it is and take this negative fraction to the other side. Okay, so I'm going to cross multiply. So that just means this is 6x squared equals 3, 4, 5, 6. And now x would be equal to the square root of 3, 4, 5, 6 over 6. And the final answer is just 24 centimeters. Now, always watch closely. Are they asking for the actual area or just the x value where the area would be a maximum? They just asked for x, so the answer to this is just 24 centimeters. Let's do another one. Question 2. The volume of a rectangular holder is given by that formula. Okay, so the only thing I know is that the height is x plus 2, but I know nothing else. Now, this doesn't happen often where they start you off with a formula. Normally, your questions would look like question 1, where you have two formulas and you need to sub into one another. This is now an exception. Question A, if the height of the box is x plus 2, determine the algebraic expression for the area of the base of the box. Okay, so let's firstly just chat about the formula for volume. So you always learned that volume is equal to length times breadth times height. So we know that the height is x plus 2, and they are asking me for the area of the base. Now, the area of the base is a rectangle, and the area of a rectangle is length times breadth. So they want me to get the product of length times breadth. Okay, guys, it sounds very complicated, but it only means I don't need 3 brackets. I just want x plus 2 and then another bracket. So I'm just going to rewrite the one that they give me. Now, if I factorize, I know one of the brackets are going to be x plus 2, and that is the height that they gave me. They are now interested in the second bracket. Now, unfortunately, this is an x cubed, so I'm going to have to factorize a cubic. So I can use the calculator, I can use algebraic long division. I'm just going to go for synthetic division in this specific case. So for synthetic division, I make the little upside down house. I can write all the coefficients. So there's a 1, a minus 8, a 5, and a 50. I know this needs to be minus 2, and that needs to be 0. I'm hoping the end is a 0, but let's see. So I'm going to add each column. So 1 plus 0 gives me 1, times minus 2 gives me minus 2. Minus 8 plus minus 2 gives me minus 10, times minus 2 gives me 20. 5 plus 20 gives me 25, and minus 2 times 25 gives me minus 50. If I add them, that's a 0. Now, what I got is the coefficients of this bracket. So that's 1x squared minus 10x plus 25. So to answer their question, what is an expression for the area of the base? I can say, therefore, area would be equal to x squared minus 10x plus 25. Question B, calculate the value of x for which the volume is a maximum. Okay, they already gave me the formula, so I can just get the derivative and make it equal to 0. So the derivative of volume would be equal to, the 50 just goes away, then a 5 times 1 just stays 5, minus 8 times 2 is 16x, and then plus 3x squared. And now they want the turning point, which is the maximum or the minimum. So I'm just going to make it equal to 0 and just reorder a little bit into a trinomial form. And if I factorize this, this would be 3x and 1x. I know there's going to be a 5 at the end, and that's a 1 because this will give me 15. This would give me 1, and together it is 16. So this is a minus, this is a minus. Therefore, x needs to equal 1 over 3, or x needs to equal 5. Now, this sum is really an exception to all the rules. Normally, I would now take both my answers and sub them into the length, the breadth, and the height, and see if there's anything that's negative, and then I would exclude that answer. This sum doesn't work that way, so we just straight away going to sub it into the big formula, and then just choose the one that gives the maximum volume. So when I subbed in a third, it gave me 50.81, and when I subbed in 5, it gave me 0. So therefore, the maximum volume happens when x is a third, and the maximum volume is 50.81. I don't know if this is meters or anything, so I'm just going to write units cubed. And for the first one, I needed to say 1 over 3 units. Question 3. A cylinder fits into 1/2 of a spherical container. The radius of the sphere is 2 root 3 centimeters. Let the height of the cylinder be x. Okay, guys, so what I said earlier, if they ask you for the volume or surface area of a sphere, they will give you the formula. In this case, they show me a sphere, but they don't ask anything about it. That's why there's no formula for it. But don't worry, you do not need to study these off by heart, only the basic shapes. Question A. Show that the radius of the cylinder is given by that formula used by Pythagoras. So they're very generous here. In a final exam, they won't tell you what to do. So for question A, if I need to use Pythagoras, I need to know that that is a 90 degrees prism, so therefore the bottom and the top is exactly the same, so it must be 90 degrees. It's not going to be skew or anything weird like that. So now I can just use Pythagoras, and Pythagoras would say, okay, hypotenuse squared is equal to r squared plus x squared. And now I need to figure out where on earth do they get the 12? But it is in the question. The radius of the sphere is 2 root 3. And even though it's the hypotenuse in that triangle that we are busy with, it's actually the radius of the sphere that we're working out. So I can put a 2 root 3 squared there. They want me to get r alone, so I'm just going to move x to that side. And therefore, if I square this would give me a 12 minus x squared is equal to r squared. Question B, find the volume of the cylinder in terms of pi and x. Okay, so the volume of a cylinder is pi r squared h. So for question B, I can just tell them I know volume is equal to pi r squared h. Now I need to sub in the things that I know. So I know that the height of the cylinder is actually an x, and the radius is given by 12 minus x squared. So it's pi 12 minus x squared, and then a normal x. So if I simplify that, it's going to be 12 pi x minus pi x cubed. Question C, for what value of x will this volume be a maximum? So now that I have a formula, I can get a derivative. I don't need to change anything there, so I can just straight away go for derivative. So volume prime will be equal to 12 pi. Okay, I'm looking at the exponents of the x, so that's why I'm just timesing by 1, and then I'm saying it's x1 minus 1. And then with the other one, the exponent was a 3, so that's 3 pi x squared. Now they want the maximum, so I'm going to just put it equal to 0, and then I can try and factorize this. So I'm already going to take out 3 pi as a common factor, and I'm left with 4 minus x squared. So therefore, if I need to solve for x, the 3 pi just goes away, and I can say, but 4 minus x squared must equal to 0, and therefore 4 is equal to x squared, and therefore x is equal to the square root of 4, so plus or minus 2. But please, always in a story sum, especially connected with a shape, anything that represents a distance cannot be negative. So because the height is represented by x, it cannot be negative 2. So the answer for C is positive 2 centimeters. Question D, calculate the maximum volume correct to 1 decimal place. So I have a formula for volume. I can now just go and sub in the x that I just found. So 12 pi times 2 minus pi 2 cubed. I can just type that in the calculator, but that would give me 24 pi minus 8 pi. So the final answer would just be equal to 16 pi, but that is not good enough if I'm working with volume and they're telling me 1 decimal space. So the answer should then be 50.3 centimeters cubed. I hope that made sense and you can now see which type of word sums they can ask you. Remember, these that I showed you across the last few videos were only about 6 examples of the possible 20. So we'll continue posting videos on this, but keep on practicing. It can be easy. Sometimes it's quite impossible, but you won't know until you haven't tried. Please now try the practice video where I post another 3 questions and then pause, try it yourself and see how close you got to the answer, or if you just understood it 100%. I know you're awesome, and I know you're working hard. Good job.
If this video helped you, please like and subscribe.
JMath.